Okay, today's lecture is going to be lecture 4, What is a function? So today we're going to be talking about functions, we're going to be talking about relations, and whether or not a relation is a function or not, because that's going to be important when we get into functions and functional analysis. So I want to start off with a definition. All right, we're going to define what a relation is. Okay, relation. A relation is a rule of assignment, between two sets, And those two sets are going to be called the domain and the range. Those two sets are going to be called the domain and the range, such that to each element of the domain, comma, there is assigned one or more elements of the range. And that is a relation. Okay, so a relation, this definition is kind of long, so let's kind of go through it slowly. A relation is going to be a rule of assignment. What does that mean? Well, when we're dealing with rules of assignments, typically what we're doing is we're taking a function. Let's say our function is f, and it's going to be taking elements from one set, let's call it x, and it's going to be mapping those elements to another set called y. So this rule of assignment is going to be between two sets called the domain and the range. So what I'm going to do is I'm going to label this x the domain. This is going to be our domain. And then this other set over here, this y, we're going to label that the range. And these are just two sets, right? So a relation is going to be a rule of assignment between two sets called the domain and the range, or x and y, such that to each element of the domain, so let's say we have a random element in the domain called x, lowercase x, and this is an element of the domain. We're going to take that x and we're going to assign it to one or more elements of the range. So for the range, let's think about an element y, lowercase y. And this is going to be our range element in our range set. So what we're doing is we're taking x and we're mapping it or assigning it to y. And when we do that, we get an ordered pair. X comma y, where x is going to be the x value. That's part of the domain. And y is going to be a part of the range. That's going to be that y value. And when I write my ordered pair, I always put the x value first and the y value second, as always. So the x is going to be mapped to y. And another way you can write this is y is equal to f of x, where f is that function or relation, x is going to be the input, and y is going to be the output. So that is what a relation is. Now, when we talk about relations, usually we can define a relation as just a set of ordered pairs. But not all relations are going to be functions, right? A function is a special type of relation. So let's define that now. Let's define what a function is, because a function is going to be a special type of relation. So let's talk about that. Okay, I'm going to define function now. What is a function? A function is a specific type of relation. A specific type of relation where each element of the domain, is assigned exactly one element of the range. So let me bring that down here. A function is a specific type of relation where each element of the domain is assigned to exactly one element of the range. Okay. So this is going to be a specific type of relation where each element of the domain is assigned to exactly one element of the range. So I'm going to underline exactly one because that's very important. So I'll give you guys time to copy that down. That is the definition of the function. And then on the next slide, we're going to talk about how we represent functions and how we can tell whether or not a relation is a function. So one way you can think about this is you have a whole lot of relations. So let's say we have this bubble. We've got this bubble, right? And all the relations are within this bubble. Every single type of relation you can think of is in this bubble. But functions are specific types of relations, right? So not every relation is going to be a function, but every single function is going to be a relation. So inside the set of relations, I'm going to write another bubble like this, that's smaller, but still inside of it. And I'm going to write functions inside here. Functions. So every single function, whether it's f or g or h, they are inside the set of all relations. But there are some relations that are not functions, right? Let's say L. L could be a relation, but it's not a function, like f, g, and h are. So every single function is a relation, but not every single relation is going to be a function because functions are a special type of relation. Okay? So that is the definition of relation and function, and that's how I want you to think about it. So we're getting very theoretical. Okay? So I have a couple more definitions that I want to write, and then I want to get into actual concrete examples of what relations and functions are. So that'll be on the next slide. Okay. So let's talk about independent variable and dependent variable. Let's do independent first. Independent variable. The independent variable is going to be the input x. The independent variable is going to be the input x. So x is always going to be the independent. Now the dependent is going to be y. So let's define the dependent variable. The dependent variable is going to be the output y. So y is always going to be the dependent variable. X is independent, y is dependent. So what that means is the y is always going to depend on what the x is. So that means x is going to be independent and y is dependent. So when I write y equals f of x, y equals f of x, what I'm saying is f is a function and x is going to be that independent variable. And y is always going to be the dependent variable because y is always going to depend on what x is. Because if I change x, y is going to change. Y is always going to be dependent on x. So that's why I say x is always independent, y is always going to be dependent. So that's the difference between independent and dependent, if you were confused about that. Okay. And now let's define domain and range, because that's also going to be important. All right, let's talk about domain. Domain is the set of all x values. Domain is going to be the set of all x values. Now, sometimes when I write domain, I'll do a capital X. That's just going to be the set of all x values. So you can write it as x, or if you know what the function is, you can write DOM F, where DOM, you can tell that just stands for domain. So domain is going to be the set of all x values. All right. So that's domain, the set of all x values. And let's define the range now. The range is going to be the set of all y values. The set of all y values. Now, typically, when I write out the range set, I'm going to use a capital Y. So sometimes I'll write out a capital Y. And if the function is known, f, then sometimes you can write range of f. That's one way you can write it. Another way you can write it is IM of f. IM just stands for image. So literally I'm saying the image of f. And then if the domain is already defined, sometimes you can write this as f of capital X. F of capital X. And that would also be the range, right? So if I take all the x values that I know of, the domain, and I put them through the function f, then I'm going to get the set of all y values, or capital Y. So I can write this range set in multiple ways, right? I don't have to stick to just one way of writing it. Okay? So that is domain and range. So now let's talk about how we can represent functions. So let's talk about representations of functions, because there's a couple ways we can do this. I'm going to put this as a little bit bigger. The representations of functions. So how many ways can we represent a function? Well, I've got 5 that I want to talk about today. There are 5 ways that we can represent functions, at least in this class. The first way we can do it is we can talk about the set of ordered pairs. The set of ordered pairs. So what would that look like? Well, we could have a set containing the ordered pairs 1, 3, -1, 4, and 4, 5. So that's a set of ordered pairs. Every single ordered pair is going to have an x value and a y value. An x value and a y value. So that's one way I can represent a function. Just a set of ordered pairs. Now, another way we can represent a function is a mapping diagram. A mapping diagram. So one of the ways I can write this is I can have a set of x values in one bubble, and then I'll have a set of y values in another bubble. And then I'm going to draw arrows between them. So let's look at the previous example where we had 1, 3, -1, 4, and 4, 5. What are the x values going to be? Because I'm going to put all the x values in this domain set over here. The domain is the set of all x values, so I'm going to need 1. I'm going to need -1. And then I'm going to need 4. 4. So that's all the x values. Over here in this range set, y, I'm going to put all the y values. So what are the y values? I'll change to yellow for this. So the y values are going to be 3, 4, and 5. Those are all my y values. I'm going to put them all in there. And then what I'm going to do, I'm going to draw arrows between them because 1 is mapped to 3. So I'm going to draw an arrow from 1 to 3. -1 is mapped to 4. So I'm going to draw an arrow between -1 and 4. And then 4 is mapped to 5. So I'm going to draw an arrow between the 4 and the 5. So all of this is to say 1 is mapped to 3, -1 is mapped to 4, and 4 is mapped to 5. And I get that from all the ordered pairs that I just wrote. Okay, so that's what a mapping diagram is going to look like. And then we can have a table. So that's going to be my third way. I can write a table. A table. So what does that look like? Well, it's basically going to look like a chart that's going to be divided down the middle, where all your x values are going to be on the left side. So I'm going to put a capital X right here, and all your y values are going to be on the right side. So I'm going to put a capital Y right there. And then I'm going to take all the x values and I'm going to put them on the left side. So all the x values, what are those? Well, I need 1, I need -1, and I need 4, right? So I'm going to have 1, -1, and 4. I'm just taking all the x values from this bubble and I'm putting them in this column, right? And then I'm going to take all the y values from this bubble right here and I'm going to put them in the y column. So across from 1, I'm going to put 3. Across from -1, I'm going to put 4. And then across from 4, I'm going to put 5. So that is to say, when the x value is 1, the y value is 3. If the x value is 4, then the y value is going to be 5. So that's another way we can write a function. We can write it as a table or a chart. A chart. That's another way we can write it. So table, charts, pretty much the same thing. And then there's two more ways that we can represent functions. And I'll talk about those in a little bit. So when we talk about functions, we can write them as a set of ordered pairs. We can display them as a mapping diagram, like I did for number 2. And then like for number 3, I can write a table or a chart. So that's another way I can do it. Okay? Now the fourth way is going to be a graph. The fourth way I can do it is I can just graph the ordered pairs. So what that means is I'm going to have a y-axis and I'm going to have an x-axis, right? The x-axis is horizontal, so I'll put an x right there. And then the y-axis is vertical, so I'm going to put a y right here. And then all the ordered pairs I can put on the graph. So let's say we have the ordered pair 1, 3, 1, 3. Well, what that means is the x value is 1 and the y value is 3. So to graph this, I would go to the right 1 and I would go up 3. I would go up 3, and that would be my dot. And then the next ordered pair is going to be -1, 4. -1, 4. So then the x value would be -1 and the y value would be 4. So to graph this, I would go left 1 and then I would go up 4. And then I'd have an ordered pair up here. And then the last one, of course, is 4, 5. 4, 5. In 4, 5, the x value is going to be 4. The y value is going to be 5. So I need to go to the right 4, and up 5. So that would be right here. And that would be my last ordered pair. So you can graph them on an x and y axis like this. So that's another way that you can represent a function. Okay. And then the last way is by formula. The last way is by formula. And this is pretty typical because you've seen this before, right? Let's say we have a function f of x, and f of x is equal to 3x plus 2. Okay. This would be an actual formula that you can write out. And then this formula, you can graph it on an XY plane, just like I did before. And you can write out ordered pairs, right? You could do a mapping diagram. You could do a table of values, right? So this formula is just a formula. It's going to be f of x equals something of x, right? So your independent variable x is always going to be in the formula somewhere. And then f of x, you could also write this as y, right? Because f of x and y are the same thing, and you can write it as this, 3x plus 2. So that's another way you can write the formula. You can use y instead of f of x, and that would be acceptable. Okay, so that's the 5 ways that you can represent a function. So now let's talk about whether something is a function or not. How can you tell if something is a function or not? That's what we're going to talk about next. So function or not? That is the question. Is it a function or is it a relation? Those two are not mutually exclusive, right? So let's talk about it. How do you know if something is a function or not? Well, you've probably seen this in Algebra 1. If any x value If any x value whatsoever has more than one y value, it is not a function. If any x value has more than one y value, then it's not a function. Okay? So let's do a couple examples of this so you can understand it a little bit better. Okay? So what this means is if a function is mapping an x value to more than one y value, like let's say y1 and y2, then this would not be a function because the x value can only go to one y value for it to be a function. Another way to think about this is any input cannot have more than one output, right? So let's do a couple examples of this. Let's say we have 3, 4. Let's say we have 5, 7. And then let's say we have 5, 9. Right? We've got 3 ordered pairs. Now I'm going to put all the x values in red. So 3 is going to be the first x value, 5 is going to be the next x value, and then 5 is going to be the last x value. But then notice I'm going to put all the y values in blue. So 4 is going to be the first y value, 7 is going to be the next y value, and then 9 is going to be the last y value. Okay? Now notice that 5 is being mapped to 7. 5 is being mapped to 7, right? So we can say 5 is mapped to 7. But 5 is also being mapped to 9, right? 5 is also being mapped to 9. So that means this x value has more than one y value, so this is not a function. This cannot be a function. Why is that? Because this x value has more than one y value, right? Let's do another example like that. Let's say we have the ordered pairs, -2, 4, 3, 6, and 5, 8. 5, 8. So I'm going to put all the x values in red, -2, 3, 5, and then I'm going to put all the y values in blue, 4, 6, 8. Notice that every single x value is only mapped to exactly one y value. So there's no repeats of x values. So this actually is a function. So I'm going to write, this is a function. Okay? So that's the difference between a function and something that is not a function. If any x value has more than one y value, it is not a function, right? Because every input can only have one output, at least for functions. Okay? So let's do a couple more examples on the next slide. Let's do a mapping diagram. Let's say we got all the x values over here, and all the y values are going to be over here, right? The first set is going to be the domain, and then this next set is going to be the range. So let's say we have 1, 2, 3, and then over here we have 4, 5, 6, 7. 4, 5, 6, 7. 1 is being mapped to 4, 2 is being mapped to 5, 3 is being mapped to 7, and 2 is also being mapped to 6. Okay? So all the x values are going to be on the left side. All the y values are going to be on the right side. So what's going on here? Well, notice that 2 is being mapped to 5 and 6. So this is not a function. Not a function, right? Because your x value has more than one y value. 2 is being mapped to 5, right? But 2 is also being mapped to 6. So this is not a function. Let's do another example where I have all the x values on this side and all the y values over here on this side. Okay. Let's say we have 1, 2, 3, 4, and A, B, C, D. A, B, C, D. 1 is being mapped to A. 2 is being mapped to B. 3 is also being mapped to B. And 4 is being mapped to D. Is this a function or not? Well, every single domain value, which I'll put in red, 1, 2, 3, and 4, they're only mapped to one y value, right? Because 1 is being mapped to A, 2 is being mapped to B, 3 is also being mapped to B, right? And then 4 is being mapped to D. So every single x value is mapped to exactly one y value. So this actually is a function. This is a function. And even though 2 and 3 are being mapped to the same element in the range, that's fine. This is still a function. It's not like any domain element is being mapped to two different range elements, right? So this is a perfect example of the difference between a function and something that is not a function. Notice that this domain element over here is being mapped to two range elements. That's not the case over here on this side. So that's the difference between something that is a function and what's not a function. Every single input can only have one output. So you're never going to have this going on. You're never going to have something like 2 being mapped to 5, but also being mapped to 6. You cannot have a less than symbol. Maybe that's another way you learned it. You cannot have a less than symbol, right? Just can't do it. So less than is not going to happen. But over here, where 2 is being mapped to B and 3 is also being mapped to B, that's fine. You can have a greater than symbol if you want to think about it that way. This is fine. You can have something like this. You can have a greater than symbol. You just can't have something that's a less than symbol, where a domain element is being mapped to two different y elements. You can't have that. Okay. And for the last few minutes, I did want to talk about the vertical line test. That's going to be the last thing that I'm going to talk about. Okay. So to have a function, each domain element can only be mapped to exactly one range element. If it's being mapped to two different range elements, then it's not a function. And this next principle is going to show that. Okay, let's talk about the vertical line tests. What is the vertical line test and what is it used for? The vertical line test is going to be used to determine whether or not a relation is a function. So let's talk about it. This is used to determine whether a relation is a function or not. So this is going to be an easy way to tell whether you have a function or not. And this only works for graphs. So here's the test. If every vertical line that can be drawn only goes through one point, then f of x is a function. If every vertical line that can be drawn only goes through one point, then f of x is a function. Okay? And then the second part to that test is if any vertical line that can be drawn goes through two or more points, then f of x is not a function. So if any vertical line that can be drawn goes through two or more points instead of just one, then f of x is not a function. So let's take a look at a couple examples of this. Okay, so let's say we have our first graph. Let's give it an x-axis and a y-axis. Let's say we're graphing y equals x squared. Y equals x squared. What would that look like? Well, the parent function x squared is just going to be a U shape, right? It's going to be a U shape. It's always going to have that parabolic shape to it, right? And let's do another graph over here. Let's give it a y-axis. And an x-axis. Okay. And let's graph x equals y squared. When you graph that, it's going to look like this. It's going to look like that. So it's basically a sideways parabola. And let's label our y-axis and our x-axis. X-axis and our y-axis. So now what I'm going to do is I want to determine whether or not this is a function, right? So what I'm going to do is I'm going to draw vertical lines. I'm going to draw a vertical line almost everywhere I can. Right? So when I draw these vertical lines, how many points do I go through? Well, the first line is going to go through only one point. The second line is going to go through this point down here, so only 1 point. And then this line only goes through 1 point. But for every single vertical line that I draw, it's only going to cross the graph at 1 point. And if they only cross at 1 point, then yes, it is a function. Okay? So we're drawing vertical lines down the graph, and we're seeing how many points they cross. Well, what does that mean for the next graph? Well, for the next graph, any vertical line that I draw, pretty much any vertical line, is going to go through 2 points, right? Notice that I go through 2 points right here. And if I draw a vertical line over here, I also only go through 2 points. Since I go through 2 points, this is not a function. This is not a function. And it's easy to see why, right? It fails the vertical line test. This fails the vertical line test because I crossed through it twice with each vertical line. Not every single vertical line, but you get my point. It's failing the vertical line test because it crosses twice instead of once, like over here. So this one is actually going to pass the vertical line test. Okay? Let me do one more before I go. So let's do an XY plane where we have a y-axis and we have an x-axis. A y-axis and an x-axis. And over here, we're going to graph x squared plus y squared equals 4. X squared plus y squared equals 4. Now, if you've ever graphed this, you know that you're going to graph a circle. You're going to graph a circle, pretty much. So I'm going to draw a circle that's centered at the origin, and it has a radius of 2. Let's just say that. It's going to have a radius of 2. Right? And that's because you can take the square root of 4 and get 2. You can take the square root of 4 and get 2. But that's not really relevant right now. What is relevant is, do you think that this is going to pass the vertical line test? If so, why? And if not, why not? So go ahead and try this one before I do it. Does this function pass the vertical line test? Is it actually a function or not? And how can we tell? So what do you think? Function or not? Well, I'll change my color to red, and I'll draw a couple vertical lines. I'll draw one right here. Let's see, I'll draw one right here, one right here, and maybe one way over here at the very edge. Okay. So how many points do these lines cross? Over here, this is going to cross through these 2 points. This one is going to cross through these 2 points, right? This one is going to cross through these 2 points. And this one is only going to cross through this point. Okay? So what does this mean? We can draw a line that passes through 2 points. Therefore, it fails the vertical line test. This is not a function. Not a function. And why is that? Because every single vertical line, well, almost every vertical line, goes through 2 or more points, right? So this cannot be a function. And it's pretty easy to see why. It's because it crosses twice. Now, you do have that line over here, right? That only goes through one point. But the definition says if any vertical line, if any vertical line. So that means if any line I draw goes through 2 points, it cannot be a function. But something like this over here, where it goes through only 1 point each time, that's when we can say, okay, it is a function. And that is the vertical line test in a nutshell. You need to know how many points each line goes through. And if it goes through more than one, then that means you are not dealing with a function. You are dealing with something else, right? And that is it. That is my lecture on functions.